Okay, so in 7-3, it's called Radioactive Decay experiment, but it's really just talking about exponential growth or decay. So we've been talking about linear functions, and this is just exponential. So really quickly, I need you to read this paragraph right here where it talks about the 19th century. Okay, so if you're looking at that, you have to understand that when it's called a half-life, it's because it starts out at a life. In this circumstance, every second it will get halved. The life gets halved. Like, literally, that's what it means. And you can look right here for the definition of how much is a half of life. Connect to science. Alright, so 1 radium has a half-life of 1,600 years. So how much radium will be left from a 1,000 gram sample after that 1,600 years? So if it has a half-life, that means you would half it, and what would it be? Oops, I meant to write it. Okay, 500 grams. Then, from there, how much radium would be left after another 600 years? And what they mean is, from the 500 grams, what would be left after that? So that would be 250, because you would half the 500. Come down to the bottom, and let's talk about if you have, now this is a different circumstance. If you have a half-life of 1 second, that means after every single second, it's going to be cut in half. But it starts out at 4, so at 0 seconds, it's at 4, but at half-life of 1 second, so after 1 second, it would be a 2. After another second, half of that would be a 1. After another second, which now we're at 3 seconds, would be 0.5. After 4 seconds, you would do half of that, 0.25. And then lastly, you would end up with half of that. Okay, so basically, there's your half-life. So now on number 4, next page, you need to have graphed those points. My red dots are those graphed points. The green, you need to connect the dots and make your line. And then we can answer the questions about it. And it says, will the amount of the substance that remains ever reach 0? Explain. Okay, the answer is no. Because if you notice, like if I asked you for a half of something, you could always actually answer my question. You're never going to say, oh, well, the half of that is 0, because that's just not possible. So, yeah, you can always half it. So, therefore, will it ever reach 0? The answer is no, because that is an infinite answer. You can answer that question with an infinite amount of numbers. So, explain that how you would like in your own words. So I also wanted to add right here for your own words that this is called an asymptote, and that I have heard, hold on, let me spell this. This word simply means that the number, whatever it is, will never reach the x-axis. It will never reach 0. It will get smaller and smaller, or if you go another way, it could get bigger and bigger if it was just so happened to be that circumstance, but it will never reach the axis, and that is called asymptote. Look it up for that direct definition. Go to number 6. Let's talk about this. Then, in a reasonable domain and range of this function, I need you to write this as set builder, which means domain, and this is not set builder, this is just like, okay, what do you call your x values? That would be domain. Here's the set builder. I need you to draw your little braces, x, such that x has to be what? So if you're looking at the graph right there, look at your x's. Please notice that your x's have to be greater than 0. So x has to be, wait, can it be or equal to 0? Alright, so no, it cannot be or equal to. So if you're looking at that, or yes it can, on the x values it can, because of how it's set up on the x's. So it's 0, 4 is what I'm saying, is where it initially starts. Okay, but then look at your range. It goes from 0, but it cannot equal 0. and then it goes up to 4, and it can be equal to 4 because, like I said at the beginning, that is your initial value. It's 0, 4, therefore that's why the domain is r equal to 0. All right, so make sure you got that written. What is the y-intercept? We just talked about this. This is a big deal. The y-intercept, I need it as a coordinate point, 0, 4, and what does that 0 represent? At 0 seconds, you start out with 4 grams. So write that in your own words. What is the absolute max and what is the absolute min? Okay, if you look, the max has to be 4 because that's the highest it can go. That's where the grams start. And then they decay from there. What is the min? There isn't one because it's an asymptote and it will never reach 0. It just keeps infinitely getting halved. Okay, now the difference in this in yellow is that it says it's not a real world situation, but it is the exact same. Here's something I want you to do for me real quick over here in the notes. I want you to write this so you actually know what each piece represents. So this is just your output. So that's how much, like if you're looking at how much it's going to be, and then the 4 represents your grams to start, or initial value. Initial weight. 1/2 simply means the half-life, or the rate at which it's changing. I said half rate. Okay, half-life. And then the x in this circumstance could represent the time, which would be seconds. Most of the time they're just going to put a t there. They're not going to put an x just because if it is time. They don't necessarily say s for seconds or m for minutes. They just say t for time. And then you come down here to number 9. Notice your domain and range. And I want you to notice what is different about your domain and range in number 10. So copy down number 9 and answer number 10. Okay, 10, the different things that you should notice is that there are no restrictions here. The restrictions in the real world situation limited us to only being in quadrant 1, whereas this one let us be in quadrant 1 and 2. So therefore it would be infinite. So that is why the domain is all real values, because there are no restrictions, whereas the range pretty much stays the same, except for it won't stop at 4. Okay, so you get to, it's still the same, but it continues past 4. So there's, once again, there's no restrictions there as well. So write that, number 10, make sure you understand all the restrictions. 11, how do the values of y change as the x increases? So go back up to the top. As x gets bigger, what happens to your y? It gets smaller, but never touches what? 0. Never touches the axis. How do the values of y change as the x decrease? The y values will get bigger. I mean, that's just pretty much it. And they never stop. Okay, 13. What is the absolute max? What is the absolute min? So write max, write min, write that down. Problem is there's none because it continuously gets bigger, like we just talked about. There's no restriction stopping it, and it will never touch 0, so we don't know how small it gets. So once again, none. That doesn't change. So now come over here to check your understanding. You're going to answer these. I'm going to try to get through them with you, and then you're going to be on your own for homework. So answer 14 through the rest, and then we'll check answers. Alright, so right here, 14 through 18, check your answers, pause. Really the only questions that I had from the other group was number 14. That exponent would be of 1 because it just remains after 1 half-life. Normally it would be an x because you don't know how many times you're going to half it. But in 14 it was a 1. Other than that, everything else was pretty straightforward. Now your job is to finish the lesson practice. It was through 25 on the end chapter review written in the classroom.